Howdy, howdy, math scholars. We are doing 9.3 today. Very similar to yesterday. You're still finding magic numbers. You're still completing a square and trying to get your equation into vertex form. Who's excited to do some magic today? Again? Yeah? Yeah? Are you? They're smiling a little bit, if you could only see their faces. So the key is today the problems will look something like this with a 2 out front. That means you are not quite ready to find your magic number until the A value out front is a 1. So we'll be using some common monomial factoring. Now, every student in the class did receive these 5 steps that they taped into their binder. So if you're watching this video at home, maybe hit pause and write these steps in your binder. Or when you get back to school, just ask me for a little slip of paper that you can tape into your binder. So let's go ahead and read together step 1 and perform that step on our first example problem. Step 1, get the x terms alone. What that means, these are all n's. So what we're going to do is basically get that negative 13 over to the other side, so all the terms that have variables can be together alone on one side. So we're going to start off with a plus 13 to move the 13 to the other side. So we'll have f of n plus 13 equals 2n squared minus 4n. So that was step 1, getting the x terms alone. Stop me anytime with questions. Step 2, factor out the number in front of x squared if there is one. So we're going to be using common monomial factoring on our right-hand side. Do you know what the common monomial is that I'll factor out? A 2, yeah, because we want that 2 to be gone, basically, before we find our magic number. So I will divide a 2 away from my first term. I will also divide a 2 away from my second term. That's been causing people some problems today. So you also need to change that negative 4 into a negative 2 by dividing it by 2. At this point, I put a plus blank because that is where my magic number will be going. Yeah.
Wouldn't it be 2n?
Oh, I got you. Yes, if you're doing common monomial factoring, you absolutely would bring an n out. We are only going to factor out the a value, though, because we need this to be a perfect square trinomial. So we need to have an n squared and an n and nothing inside. But you're right. If we were truly doing the greatest common monomial, we would be pulling out 2n. That was kind of scholarly. Okay, we're ready to do our magic number. Who knows what our magic number will be over there in the blank on the right? A positive 1. Very good. So we're going to put a positive 1 right here. We're technically on step 3 right now. It says find the magic number and add it to both sides. Make sure you add the same amount to both sides. That's the key. Think of our teeter-totter here. I didn't actually add a 1 over here on my right side. I added a 2 times 1 because you have that 2 looming out front, okay? 2 times 1 equals 2. So it's kind of like I added 2 to this side of my equation. I need to also add a 2 to this side of the equation. Does that make sense? Even though the magic number was a 1, the value that we added on was a 2, because 2 times 1 equals 2. We can go ahead and combine some like terms. This 13 and 2 is 15. At this time, we can do our step 4, which is factor our quadratic. This here is our quadratic. I want to write it as a square of a binomial. Do you know what would go in that binomial? Yeah? N minus 1. Good. Now, if you're ever stuck and you just cannot figure out what goes in this binomial, just think old-fashioned factoring technique. What numbers multiply to a positive 1, add up to negative 2, negative 1 and negative 1. And then we're pretty much done. We have to do our final step. Get the y alone to have vertex form. So we'll just move the 15 way over to the right-hand side. So can we live in over there? And voila! Just like magic, we're in vertex form. All right, for a ticket though, I do want my vertex list now for fun practice. Abby?
1, negative 15.
Perfect. Vertex is 1, negative 15. How do we do on that? Any questions? This stuff is not the easiest. It's a lot of steps. It's almost like we're adding 2 additional steps on because of that A value. we had to deal with. All right, let's try another one. Go ahead and draw it down. So let's go ahead and move the 18 over. That just kind of clears some space so we can do magic number stuff and some factoring. That should be a plus sign. So if 18 plus g of x on the left-hand side, we'll have 3x squared plus 12x on the right-hand side. So I shouldn't use the word greatest common monomial. I should just say we need to factor a 3 out of the right-hand side. Make sense? We do not want this 3 there anymore. We can't do the magic number until the 3 is gone. So I will take 3x squared divided by 3. I will take 12x and divide it by 3. And then I'll put a plus blank, because we will now be prepared to find our magic number. For one ticket, what is our magic number? Sydney?
36.
No, you don't want to find it from the 12. You want to find your magic number from your new and improved B. Try again. Yes, 4. Okay. So she did 4 divided by 2, got 2. Remember that number. And then 2 squared is 4. All right, at this point, we need to remember that we suddenly added something to the right-hand side of our balance, our equation. What do we need to add to the left-hand side to keep it balanced? Yeah? No. So if you add a 4 on this side, it's actually equivalent to adding a 12 on. Because the 3 times 4. So we're going to add a 12 on. Does that make sense? Yeah. So we're adding a 12 on to the side to keep it balanced. So I'll just do a plus 12 right here because I'm kind of out of space. 12 plus 18 is 30. And now we can go ahead and work on factoring our perfect square trinomial. So what numbers add up to 4 that multiply to 4? That's easy. 2 and 2, right? So we'll write it x plus 2 squared. We still doing okay? How are we on understanding why I'm adding the 12 on? Are we okay? Why is it 12? 12 was not your magic number, but it was basically the amount you added onto that side. Okay, and then we'll finish it off by just getting our 30 over to the other side. So we're in vertex form. For one ticket, what's my vertex? Brooke?
-2, -30.
Good. -2, -30. All right, do you want to try one? Oh, yeah, question? This 4?
Yeah.
Like, where's it go? These 3 kind of like collapse down and disappear when I write it in factored form. Does that make sense? Because I'm basically factoring this down into this product of x plus 2, x plus 2. Because 2 and 2 will multiply to 4 and add up to 4. But instead of writing it like that, I write like this. And then they're gone. Yeah?
So where did you get the
This 2? I selected 2 because those were the numbers that added up to 4 and multiplied to 4. So it's old-fashioned factoring technique, technically. Instead of, like I said to math, instead of writing it twice, you just write it once with a square. Okay. I'll help start you off on this one, but then I want you to try to finish it all by yourself. So on this one, I wanted to help you start it off. I'll help you on the first 2 steps, and then you take it from there. Do you know what my first step would be? I guess I'll let you write it down first. What do you think we would do first? Let's get rid of the 19 first. That's what I was thinking. So let's just move that 19 to the other side. She's on top of it. She's already thinking about the a value, which I love that you're thinking about that already. So we've got a negative x squared plus 18x equals y plus 19. So she's exactly right. The a value you're going to want to bring out is a -1. And when you do that, it will turn your negative x squared to a positive x squared. It'll turn your positive 18 x to the negative 18x, and then you'll be ready to do your magic number stuff. So I'll let you go ahead and try the magic number stuff, and try the factoring, and then we'll regroup and kind of check and see how things are going, okay? Okay. What did you guys get for the magic number that will go here in parentheses? Louise?
81.
81. Good. So if you're stuck on how she got that, she takes the negative 18, divides by 2. What's that give you? Negative 9. Remember negative 9 for me, okay? And then square negative 9, get the 81. So what I'm going to do now is take the negative 1 times the 81. That's a negative 81, and that's what's going to get added to my right-hand side. Okay, that's going to keep everything balanced. At this point, you can combine the 19 with the negative 81. Probably need a calculator for that, unless you're super good with mental math. So negative 81 plus 19 is going to be a negative 62. And on this side, you're ready to do your factoring. So it's the old-fashioned factoring technique. What numbers multiply to a positive 81 but add up to a negative 18? Negative 9, the number I told you, remember that number. Remember when I stood here and said, remember that number? I told you to remember it on purpose, because that's the number we're going to go with. It's x minus 9 and x minus 9. We'll just write it as x minus 9 squared. And the only other thing left to do is move the 62. So I think here's what our final answer looks like. We'll have our negative 1 out front. That basically just tells me my parabola opens down towards the ground. Hey, if your parabola opens down towards the ground, does it have a maximum or a minimum? Maximum, yes, because it's like the vertex is a mountain peak. So my vertex is a maximum. Here's your vertex. What is the vertex for my last tick of the day, Hannah? 962 is our vertex. Sound good? All right, we'll stop the video, and you already have the worksheet. It's like the back side of last night's. I think you'll be good. You can have the rest of the time to work on it. Just see me if you have questions.